What's up, everybody? This is Mr. Bergman here with the Jonas Brothers. Jonas Brothers and I go way back, so we've been kicking around some ideas, and we want to do this collab. So here it is. Frequently asked questions. Partner project. This is groups of one or two. When is it going to be due? After 2 in-class work periods. Would you have to submit a video recording to Google Classroom? What's it worth? 100 points, same as a quiz. What you do for a good grade? You should preview your work with me. This is a collaborative effort. I want you to make sure. Although I am the person who's setting the challenge, I also wanted to be the person to give you the feedback that you might need to do well. And I want to work with you and give you pointers and tips and all that stuff. So let's check in frequently, and I can't wait to see what you come up with. Of course, the second thing you can do is you can check the rubric, which is actually the same as always. Check to make sure you're hitting all those extensive list of things you got to be doing. Why are we doing this? Well, we want to solidify chapter 6 and 7 concepts with a full graphical analysis. We also want to just get really good at tackling tasks and reporting those findings. I want you to get really good at telling the research story in the format of a STEM presentation. So speaking of the rubric and things that we are doing, here's what we're not doing. There's actually no other related questions apart from the ones that are normally assigned in the rubric. We're not having a test. We're not having alex.com assignments. We're not doing any collaborative Desmos slides. But I will ask you to have Edpuzzle 8.1 finished by the time we get on the same day that this is due, so we can get started on chapter 8. Central question: what is the temperature of the water in the bucket? It's going to get hot, so I want to know what is the temperature of the water in the bucket, and you'll see what that means when you watch the video. Speaking of the video, here's what it looks like. I'm going to give you a YouTube video, and then you're going to take the numbers from that and put them on Desmos, analyze it, put all your analysis onto Google Slides, do a video recording, and put that video recording onto Google Classroom. Here's the research workflow. Like I said, you're going to start with video, and then we have to think about variables. I'll tell you right now, it's time and temperature. And unlike the SAND project, which is really weird and backwards, yes, the independent variable x is going to be time, and the y is going to be temperature. Then you can turn that into a table of values. And from the table of values, you can, on Desmos, I want you to graph 3 different regressions. I want you to graph the cubic, the square root, and the exponential. And it's going to be kind of a multiple choice, like is it A, B, or C? Which one is it going to be? This event that I've given you, the science on it is pretty clear. It's been kind of hammered out for a while now, and I want you to figure out what it is. Which of these 3 regressions really reflect the nature of this event? Which regressions have a well-known equation in the same format that governs this event? So I want you to do some research, some scientific. It might be from science or from geometry. Find some formulas that will govern this event. And then you can also look at the R-squared values. Which regressions have R-squared values greater than 0.99? You can also look at the shape of the graph. If you graph all 3 of these, maybe they won't all behave like as you go past the data. Maybe one will go up when you expect to go down, or maybe one will go down when you expect it to go up as x approaches infinity. And so the shape of the graph kind of matters, and so you have to ask yourself which regressions have features a graph whose features reflect the experiment. So those 3 different conversations will help you choose a parent function to model your data. And from that, you can get the features of the graph, and you can answer all the related questions that I've given you as part of the rubric. And you can also answer the central question, which is what is the temperature of the water in the bucket? When you're choosing a parent function, like I've already said, there's 3 different parent functions that have 3 different regressions, and you got to choose. You got to figure out which one it is. And to help you do that, you should examine the research, the R-squared values, and the shape of the graph for all 3. So it's helpful, even in your own presentation, to have a chart like this. And each of these three conversations is going to, on the left, is going to be applied to each of the three parent functions on the top, and they're either going to green light or they're going to red flag, and thus eliminate the parent function for consideration. On your rubric, which is this, we're going to use the same rubric as always. There are some things that, for example, I want to highlight. There's no other related questions, as I've already said, but there are some new things that are coming into play now because we just know more math. We've finished chapter 6, so I want you to find the inverse of whatever data you get, or whatever regression you choose. I want you to find its inverse. I want you to go equation table graph on that inverse and do a vertical line test. I want you to do chapter 7, and now that we've also finished chapter 7, if there are any asymptotes, I want you to find them and report them. So what can you do now? You can actually get started. I want you to find this Google slide on Google Classroom. I want you to choose any data that you see on the next slide, and I want you to watch the video. It will be an event you must analyze. You can start a Desmos table and graph, and you could even create a Google slide called the Google Cooling Project. If you know who your partner is going to be, you can share them with your partner and with me, and that's what the data looks like. Thanks, y'all, for listening, and I can't wait to see what you come up with. Feel free to email me with any questions, and bring something to class tomorrow that you've already started. Take care.